When an atom is excited by the incident X-ray upon de-excitations, there are two phenomena. The first one is called X-ray fluorescence. The second one is called Auger phenomena. In this video, I will explain why for certain elements, for certain atoms, XRF is dominant, while for lighter elements or for small atoms, Auger phenomena is dominant. I posted the similar question on YouTube community that which process is dominant with low atomic number, and the correct answer is this one, Auger phenomena. When we want to explore what type of element exists, what is the concentration of that element, we usually use X-ray. So when we bombard X-ray on certain elements, the core electron ejected. And this is now called photoelectrons. Now this atom is basically excited atom. This is now excited atom. Now this atom wants to become stable, so it has to de-excite. So upon de-excitations, we will get fluorescence in the form of XRF or Auger effect. When this vacancy is filled by the higher shell electron as a result of emission of photons, so this photon is exactly equal to the X-ray. This is why it is called X-ray fluorescence. Fluorescence basically means emission of photons. And when the wavelength and energy of this photon is exactly equal to X-ray, this is why it is called X-ray fluorescence. And this is called radiative phenomena. Now there is also a possibility that this vacancy is filled by another shell electrons, but instead of photons, there is a there is an ejection of outer shell electron, and that process is basically called Auger. Very interesting diagram. On x-axis we have atomic number of the elements. So it starts from 0 to 80, and it's usually go to uranium 92. On the y-axis we have X-ray fluorescence or Auger yield, mean the productions. So it's from 0 to 100 or from 0 to 1. So we can see here in this blue line, this is the probability of the Auger effect. So we can see that at lower atomic number, this effect is dominant. This is why I asked in the community phase. This is dominant. When the atomic number increases, this effect is basically starting decreasing. At the same time, the XRF, the X-ray fluorescence phenomena, is basically started increasing here. Why XRF? Why XRF is not detecting lower elements than Z lower than sodium? That is the reason here, that because there is no dominant fluorescence in these lighter elements. This is why the probability of XRF is low. Another important thing is the yield is basically approximately proportional to the fourth power of atomic number. So if we increase this atomic number, so the yield increases significantly. But if we have lower value of Z, so this yield is basically lower because the fourth power contribute a lot here. Yes. So if this value is smaller, so the effect will be very small here. If we increase this value, so the effect will be very high. This is why we have this shoot up in this yield in the form of XRF. If you know other reasons that why for heavy elements XRF is dominant, while for lighter elements, for lighter atoms, Auger phenomena is dominant. So please do comment your answer.